So greetings, my name is Shreya Srivastav and I have participated in Accenture Innovation Challenge 2022. The name of my project is BlockPay, which is a billing and asset tracking system and is designed to primarily function as an anti-theft and anti-smuggling application for electronic products. What it does is that it stores the meta details of the product like shipment, manufacturing details, servicing details, etc. on a blockchain network alongside storing the unique identification details of the customer such as the other unique Aadhaar card number. It is a web-based application which offers all the traditional functionalities which is offered by a conventional billing application. Besides all this, it also offers some extra features for better security, authenticity, and customer experience. The key highlight of BlockPay is it stores the details of the product as well as the details of the owner on a secure, immutable, and decentralized blockchain network which is difficult to hack or tamper. Even if a little information is changed on the existing data on the blockchain, it would generate a new hash value. This makes the data on blockchain immutable and resistant to any type of temperament done. Suppose if a customer visits a local retail store in order to purchase a product, the seller ensures that he stores the details of the product as well as the identification details of the customer like Aadhaar card number on a blockchain network. And after doing so, he receives a unique hash ID which he hands over to the customer. But suppose if the product gets stolen, the thief would eventually visit the retail market in order to resell the product. When the thief visits the store, he would be asked to provide the unique hash ID which he might have received at the time of purchase. Since the thief is not the legitimate customer of the product, he would not be able to provide the hash ID. Hence, he would not be able to verify himself. Even if he somehow provides the unique hash ID, he would not be able to verify his ownership over the product because of his Aadhaar card details. Since Aadhaar card number is unique for everyone. This would help shopkeeper to alert the local authorities that there is some discrepancy and the thief could have been involved in a major smuggling racket. Here we must have a look at the architecture of BlockPay. The front end is designed using React.js, which is connected to an IPFS server running on the local system. The IPFS server is responsible for storing the details of the product as well as the identification details of customer on a unique blockchain network. Other functionalities of BlockPay is offered by a Node.js server which is connected to a MongoDB database and hosted on a Heroku cloud. Here we can have a look at the data flow. The customer provides his details and the shopkeeper also provides the product details which is fed into the front end of the application. From here, the data is stored on a MongoDB database. A copy of the bill generated is sent on WhatsApp and email to the customer. The records present on the MongoDB database can be fetched on demand using a front end of our application. The meta details of the product as well as identification details are stored on an IPFS network, which generates a unique hash ID which can be used anytime for verification. Other relevant features include user authentication using store ID and password, which is built using MongoDB and Node.js. It has a built-in interactive shopping cart with a price calculator. It stores the details and product bill on a centralized MongoDB database, which can be fetched on demand by using the invoice number. The records are arranged in the descending order of the time at which the transaction had occurred. It is a built-in QR code scanner for automatically fetching product information like shipment details, place of manufacture, etc. The bill is sent on WhatsApp and email of the customer using Twilio API. It is a cross-platform web-based application which is designed using MERN-Stack for efficient usage on desktop, laptop, etc. It also has a feature of predicting the resale value of old used electronic products using machine learning algorithms. The technical stack which we have used in our application are as follows. For the front end, we have used React.js. For the back end, we have used Node.js, Express.js, and Python Flask for deploying the machine learning model as an API. The database we are using is MongoDB, which is used to store the transaction history as well as the bills. The blockchain like storage which we are using is IPFS, which is Interplanetary File System. We have deployed the application on Heroku Cloud. The API which we are using for sending bill on WhatsApp and email is Twilio API. Other tools include VS Code, Git, Postman and Client. The further improvements which we are planning to involve in the product is biometric authentication for better security, analytics of sale at the store by visualizing data on products sold and delivering insights from the sales by using machine learning algorithms for better business policies, and a usage of interactive voice assistant. This product has multiple advantages which have not been listed in the PPT but have sufficient potential to evolve as a 360-degree application. Some of the features include minimization of